The next operation for the linked list is insertion. So you will see the inserting the new node. So here we have to check the overflow condition. So that is, we have to check avail is equal to null. Okay, we have to check avail is equal to null or no free memory cell is present in the system. Okay. So here for doing the insertion there is 4 cases. First one is inserting the new node at the beginning, the next inserting the new node at the end, then inserting the new node after the given node, then inserting the new node before the given node. So these are the 4 cases when we are doing the insertion operation. So we will see one by one. The first we will see inserting the new node at the beginning. So for example, consider this is a linked list we have taken. Okay, so this is the linked list we have taken, and what we are going to do, we are going to insert the new node at the beginning here. Okay, we are going to do new node, we are going to insert the new node at the beginning here. Okay, so here what we have to do is, first we have to find what is the starting node. So this is the starting node, right? So here first we have to find the start, which is the starting node. Okay, after finding the starting node, what we have to do, we have to insert the new node before the starting node. So for that, first we have to allocate the memory space by using the malloc function. Then we have to create the node. Then we have to assign the value for this node. So for example, I am assigning the value for this particular node. Okay, so this is a start node here. I will draw here. Okay, so this is the new node and the value is 8. Okay, so the value is 8 here. Then what will happen, this address part, so this address part contains the address of the start node. Okay, so it contains the address of the start node, and what will happen, the start, we have to change the start also. Now what will happen, this will become as the start. So this is a procedure. So we will see the algorithm, then I think it will be easy for you. So we will see the code, then we will go to the algorithm. Okay, so this is the linked list we have taken, and in a code, first it is struct node star insert, it's a function, insert underscore beginning start node struct node star start. So first what we have to do, we have to create the new node. So first we are, by using the structure concept, first what we are doing, we are creating the new node here. Then next we are using one variable, that is a num. So it is for storing the value for the new node. Then next we are, by using the printf statement, we are printing enter the value. Then by using the scanf statement, what we are doing, we are getting the value for the num. Okay, we are getting the value for the num. Then next we are allocating the memory space for the new node by using the malloc function. Okay, then next we are assigning the value to the new node. So new node tends to data is equal to num, so this value will be stored in the new node. Then we have to assign new node tends to next is equal to start. Okay, new node tends to next is equal to start. So what will happen, so for example, consider this is the new node we have created and with the value 8. So what will happen, new node tends to next, so new node tends to next. So what will be the address part, this start node's address. In address part, it contains the address of this particular start node. So that is the meaning. Then start tends to new node. So next what will happen, this new node will become as a start. So now this is the start. Okay, this is the start. Then next we have to return the start. Okay, so this is the code. So first what we are doing, we are creating the new node, then we are getting the value for the num. So first we have to declare the variable, then by using the scanf statement we are getting the value. Then next statement, we have to allocate the memory space for the new node. So for that we are using the malloc function. Then we are assigning the value for that particular new node. Then we are assigning the address part. So what is the address, this start node's address. Then we are changing the start node as a new node. So this is the code. Then algorithm, So this is the algorithm. So here already I said in the starting of this video, I said we have to check the overflow condition. So we are checking avail is equal to null. Okay, here we are checking avail is not null. Why we are checking this condition is we have to check whether any memory space is available to insert the new node. So we are checking this condition. So if this condition is becomes true, means what will happen? Okay, it will go to the step 7 and it will exit. Okay, if it is not null, okay, if it is not null means what will happen? It will go to the second step and we are checking new node is equal to avail. Okay, new node is equal to avail. Then we are checking avail is equal to avail tends to next. Then what we are doing, we are assigning the value for the new node, then we are assigning the address for this new node, then we are changing the start node. So this is just for comparison. I have added the code here also, so it will be easy for studying the code as well as the algorithm. So it is data structures and algorithm. Mostly they will ask you to write the algorithm. So if you write the algorithm like this means it is more advantage for you. So the same thing only we are using. So first we are using this function, then by using the struct we are creating the new node. So instead of that statement, what we have to write an algorithm, new node underscore node is equal to null. Then what we are doing, we are getting the value for the num. Then by using the malloc function we are allocating the memory space. Then the same thing, so you can check. So we are assigning the value for the new node, then what we are doing, we are assigning the address for the new node, then we are changing the start, then we are returning the value. Okay, so this is about inserting the new node at the beginning.